Hello all. Welcome to episode 27 in hexadecimal of Debugging TV Frames program. You can type your questions during this episode. If I can't answer particular questions now, I then post answers on their website, debugging.tv. We now resume our kernel space journey. We started in episode 25 in hexadecimal. The topic of this episode today is live code modification to model abnormal software behavior. It should be very short session, no pictures, only demonstration of WinDBG session. And here I already connected WinDBG to, it is waiting for a breakpoint, and we are running operating system. There's a screensaver currently running. So first what we do, we break. So what we do here, we open a log file. Let's name it 27txt or log. So then we fix symbols, do reload. So our goal is to model abnormal software behavior. We decided to model memory leaks, kernel pool leaks, paged pool leaks, non-paged pool leaks, all at once. So how do we do that? So first of all, let's see what functions are available that free kernel pool. So for this we use X command. So we just want to see. So suppose we don't remember exactly what functions are. So we just remember that something like free X free pool. And if we append the star, so we get all these functions. And if we disassemble, we see that X free pool X calls X free pool with tag function. And for example, if we choose now, if we disassemble another function, we see it jumps. So basically, what this means, so in the previous one also jumps. So what this means is that all these functions that free allocated pool entries, they all call X free pool with tag. And to model memory leak, we just modify its code. So if we take address, or we can use a symbol and disassemble a few bytes, we see that this function prolog pushes registers. So what we do, we just replace the first instruction with return instruction, ret instruction, and so we hope that every 3 will be ignored. And by doing that, we effectively model memory leak. And so, to modify, we use another command A, assemble, and here we enter return. And if we disassemble again this address, we see that in return instruction, and we see the second one is not what we expect, so it differs from push RBP, but this is because we modified just 1 byte, and the rest was unmodified, and it forms the part of that different instruction. But that instruction will never be executed because the first one is return. But before we continue and hope that some leakage occur, let's for baseline check virtual memory statistics in bang VM command. And what we see here is non-page pool usage compared to maximum, and also page pool usage. And so what we do now, we also dump pool usage statistics, say for non-page pool, sorted by non-page pool usage. 3 pool use 3 command. So we scroll a bit higher. So, okay, so what we see, this is our top consumers, non-paged pool. Not much. It's in order of just several megabytes. So, okay, so we modified free pool, X3 pool with tag function, and we now continue execution. Type go and switch to operating system, and maybe do some activities like writing a notepad. Internet Explorer. And what we do now, we go back to WinDBG and do break. And let's now see virtual memory statistics. So non-paged pool is 53 megabytes. If we search for VM output, before the usage was 34 megabytes. So we see 20 megabytes increase, and page pool usage now is 76 megabytes. And if we compare with the previous one, we see it was 62. And so let's continue again a bit. Switch to close now. Run Internet Explorer, for example. Close again. Run run Explorer. Run disk. Okay. And let's go back to debugger and do break again. Let's compare virtual memory stats. We see page pool usage now is 100 megabytes. Non-page pool is now 84. So you see all these steadily increases, all this usage. And if we look at non-page pool usage sorted, and let's go. You see how much it increased. So there are many more pool tags appear that were not freed, if you compare. Basically, I published this log file after this session, and you could compare all these allocations. So what you see that we effectively modeled memory leak. And let's say we want to stop this memory leak, and we want to change code back. For this let's this is our function. We want to change code back, and remember it was push ABX. If we go to the beginning and look at what we disassembled. So initially it was push ABX, and so let's try to assemble and do push ABX, change, and we see we have an error. This is because assembler in WinDBG doesn't understand 64-bit language, assembly language, such as ABX, for example. So in order to do assembly here, if this is not a simple instruction like ret, which is the same in 32-bit and 64-bit assembly language, in order to come back, we need to do memory write instead of assembling. So if you go back to initial code, we see that the byte equivalent to push IBX was FF F3. So let's remember this. And this time, what we do, we use another command, EW, to write a word. So we use this address, the same address. So we use command EW, and then we try to write this byte command. And then let's verify. Instead of push IBX, we see completely different instruction. But this is because we forgot about little ending byte arrangement. If we go back to, so instead of FF, F3, you see the reverse was written F3, FF. So what we need to repeat this command and use F3, FF. So now we have the proper function prolog. And we can type go and continue. Let's switch to operating system and do some commands. For example, launch WinDBG. Launch Explorer. Launch Internet Explorer. And now we go back and do break. And let's check now virtual memory statistics. You see, if you compare with the previous, it didn't change much from the values we had last time. So we effectively stopped memory leak. And this is the end of demonstration. I later post the log. And now the usual add slide of upcoming training sessions and free webinars, and nothing new here since the last episode, so I skip it. And so thank you for watching this episode. Please later check out the slides and recorded video from debugging.tv. And the next episode should be next Tuesday due to an Irish bank holiday on Monday. And we continue with live kernel debugging. Okay, thank you for attendance. Bye-bye.